problem I. So here we're looking at the square root of x times y. So it's probably best to first write that as the quantity x times y to the 1/2 power, which remember is the fractional root for a 1/2 or for a square root. Okay, so first we're taking the partial derivative of the x variable. X shows up in our term, but it's trapped in parentheses to an exponent. So remembering the generalized power rule, or could be called the chain rule, where first thing we do is take the exponent and write it out in front of the parentheses, subtract 1 from the exponent to get negative 1/2, and then we always keep the inside of the parentheses the same as they originally were. But now we need to take the derivative of the inside, but remember, this is a partial derivative about the x variable. So we need to do this focused on x, where x turned into 1. So we just have 1 times y, or y. And then we need to rewrite our answer. So focused on the 1/2, we know that we have a 2 in our denominator because we have a negative exponent on the parentheses. Then we need to put those parentheses in the denominator so that they can have a positive exponent. But this y over here is really like y over 1. It's technically in the numerator, so it needs to go in the numerator of our problem. And basically, that's your answer. You could rewrite it with radical forms because that's how the question was, but you don't need to. Okay. And so now we're ready to find the partial derivative about the y variable. So again, we are taking a derivative of something that's in parentheses to a 1/2. So we put the 1/2 out front, subtract 1 from the exponent, keep the inside identical, and now we need to take the derivative of the inside about the y variable. So this y will go to 1, which gives us just an x. And again, for our answer, we focus on a 2 that's in the denominator, a negative exponent, which causes us to bring the xy to the 1/2 to the denominator, and just an x that's not seen in a denominator, so it belongs in the numerator, and we have our answer. Or again, we could always write it in radical form.